Hello, everybody. I am Professor Walid Amar from Zarqa University, and I am going to take you on a quick tour through our research work that has been prepared in the labs of Zarqa University. So let's get started, please.
We are here experiencing our experimental prototype for our paper research about the modified converter known as a high gain quadruple diode boost converter, abbreviated as QDBC. This converter is used to step up the DC voltage from one level into higher levels, and it could be used for solar applications, for electric drive systems. And let me please introduce the components of the prototype, the experimental prototype.
We see here an inductor L1, which has an inductance with a value of 2.2 millihenries, and inductor L2, which has a value 1.1 millihenries, and inductor L3, which has a value of 2.2 millihenries.
We see here the output capacitor, which has a value of 470 microfarads, and we have this capacitor C3, which has a value of 150 microfarad, and this capacitor has a value, this is C2, has a value of 220 microfarads, and this one also, C1, has a value of 220 microfarads. The load consists of a resistor of 200 ohms in series with an inductor. Okay, we are operating on this switching ratio. We'll do another experiment where we use another value for the switching ratio to see the behavior of the converter. Okay, we see here also the applied voltage, the supply voltage, which is about 10 volts, the source current, which is about 0.8 amperes, the generator voltage at the output has a value of about 28 volts, and the output current, the load current, is about 0.129 amperes. Okay, 0.130 amperes almost. Okay, in the next step we will use higher switching ratio to see how it can produce higher voltages at the output, and then in the last and the final step we'll use a DC motor to see how it operates with the DC motor in case we use it for electric drive systems. So again, we use here higher switching ratio D in order to get higher voltage, and as we apply a supply voltage at the supply with a value of 10 volts, we get at the output, as we see, about 100 volts by using higher switching ratio, which gives a good indication about the performance, the dynamic performance of this converter, as it is shown throughout the paper, the research paper, the experimental steps, and all these things proves that this converter can produce higher voltage than does the boost converter. Okay, as we see here, if we use this converter for driving a DC motor or an electric drive system with a DC motor or with another type of motors, okay, it works very well. The specification of the motor are within the research paper. Okay, we see that the voltage across the motor is about 16.5 volts. Okay, and that's good. We have here Arduino Uno for generating the gating signals for the MOSFET of the converter. Okay, yeah. And sometimes we also use the function generator. Okay, this is the brief description of the experimental prototype and the experiment we are doing here. Thank you very much.